Now in this video, we are going to see that how to take the integration involving the trigonometric functions, but we will put some light on the case 2. In my previous videos, I have explained you that if you have two trigonometric functions, means one trigonometric function and the other trigonometric functions, it means you have two trigonometric functions and one of them is exactly the derivative of the first trigonometric function, then always consider the first that trigonometric function as your composite or the complex function and consider the function as the inner function and always consider the power as the outer function. Why? In order to apply the power rule. Now here in this video we will put some light on case number 2. What if you have only one trigonometric function? So if you have only one trigonometric function, so in that case always consider the angle as your inner function. And that trigonometric value, sine, cosine, tangent or anything else written here will be considered as the outer function. You all know from my previous video, it is very obvious that once we see that the derivative of the inner function is written and once we decide to apply the u-substitution method, then we have to write the inner function as it is, but we take the antiderivative of the outer function. Let's see, if I'm saying that the trigonometric function will become the outer function, so sine changes into negative cosine, cosine into sine and so on, and you can see that the angle which you suppose as the inner function stay as it is. Let's practice few questions by using the long method first, and in the next video I will tell you how to solve such kind of the question with the short method. So here you can see first thing is you are analyzing that there is only one trigonometric function. So once it is the one trigonometric function, you know that the inner function will be considered as the angle. So here sine 2x, so 2x is your angle. So you will consider u equals to 2x. After that, you always take the derivative with respect to x. So 2x changes into 2. Then you bring the dx on the other side. So it will give you 2 dx. Now compare and change all the x terms into u terms. So here sine 2x. So sine stay as it is, and you already said that 2x is equal to u. So in place of 2x you will write 2u, and now left 2 dx. So this 2 dx you can see over here, which is equals to du. So never write the du in the beginning. We always write the du at the end of the integrand sign. Integrate. Now after that, it is simple. Sine u. What is the antiderivative of sine? That is negative cosine u and plus c. Now change the u into 2x. So you can write negative cosine 2x and plus c. Hope you will find this so easy. Now here again you have only one trigonometric function. So consider the angle as the inner function. Name it as u. So you will write u equals to pi x. So take the derivative with respect to x. So derivative of pi x will be pi. Bring the dx on the other side. So you will get pi dx. After that, convert all the x values into u values. How? Let's see. cos, there is no changing of the cos on the other side. So write the cos as it is. And pi x changes into u because you suppose it in the start. Now you have pi dx, which is written in the question, and you know that pi dx came it as du. So write down the du. Now you know what is the antiderivative of cosine. It's sine u because the angle is u, so you write u. And since it is an indefinite integral, so write the constant of integration. Now u, what is your u? U is your pi x, which you just in the start you said my u will be pi x and plus c. That's so simple. Okay, now solve one more question and see some other stuff. So here you have 2 sine 6x. Here again you have only one trigonometric function. So consider the angle as your inner function and name it as u. So u is equal to 6x. Take the derivative of the inner function with respect to x, which gives you 6. Bring the dx on the other side, so it will give you 6 dx. Now come on to this side. Now here you have sine 6x. So sine stay as it is. In place of 6x, you can write here u. Now what is left? In the question, you can see that you have 2 and dx left. Now here on the other side, you have 6 dx. So bring the 6 on the other side by dividing it on the both sides. You can write it 1 over 6 du equals to dx. So in place of this dx, you can write 1 over 6 du. So 1 over 6 before the integral sign and du at the end. Now you can see the 2 stay as it is because there is nothing here in the 2. So keep the 2 as it is, and since it is a constant number, write it in the start. It will become 2 over 6. Now 2 over 6 will gives you 1 over 3, and you know the antiderivative of sine is negative cos. So negative write in the start and it will be cos. U stay as it is and in the end plus c. Now convert the u into 6x. So you can write negative 1 over 3 cosine 6x plus c. That's all. Now one more question in which they are saying cosine 7x. So quickly let's do that question. Again you have one inner function. Okay, one trigonometric function. Consider the inner function as your u. Okay, consider the inner function, that means the angle as your u. Take the derivative with respect to x. It will give you 7. Bring the dx on the other side. You will get 7 dx. You don't have 7 in the question here. So divide both sides by 7. So you will get here 1 over 7 du equals to dx. Convert all the x values into u values. You have u 7x. So you can write here cos u and dx equals to 1 over 7 du. 1 over 7 you will write in the beginning, du in the end. Now you know 1 over 7 is a constant, so you wrote as it is. Antiderivative of cosine is sine and u stay as it is plus c. Now write the u in terms of x, that means it will equals to 7x and plus c. So easy if you understand the question and if you are familiar with the derivatives also. Here again you have one trigonometric function, so take the angle, name it as u because it is your inner function. So it is 1 over 2x. So derivative of this thing will be 1 over 2. Bring the dx on the other side, you will get 1 over 2 dx. You don't have any 1 over 2 in the question, so divide both sides by 1 over 2 and you will get 2 du equals to dx. Once it is done, convert the x values into u values. Write the cosecant square as it is, x over 2 you just you already said it is equals to u, and dx is equals to 2 du, the constant before the integral sign, du in the end. And now write down the 2 as it is. Antiderivative of cosecant square is negative cot, and this angle is stay as it is. In the end we will write the plus c. Now negative 2 cot, change the u into x form, that will be x over 2 plus c. So hope you can understand all these questions. The basic thing is that you should know what are the derivatives of the inner functions. Again here last question, here you have cosine 1 over theta. So here you have one trigonometric function. So angle will be your u, that means 1 over theta. Take the derivative with respect to theta, means you will say that the theta is your function, and 1 over theta, derivative of 1 over theta is negative 1 over theta square. Bring the d theta on the other side. Now you can compare that you don't have in the question negative sign, so bring the negative on the other side. So you will get 1 over theta square d theta. Now look at this, change into u form, cos stay as it is, 1 over theta changes into u, and now left 1 over theta square and d theta, which is equals to negative 2u, negative right in the beginning and du in the end. So now take the integral and integrate it. So negative stay as it is, antiderivative of cos is sine, u stay as it is, in the end you write the plus c. Now negative sign as it is, and the u changes into 1 over theta and plus c. So it is very simple.